Yeah, so hey everyone, we'll be starting in a minute, so I'll just wait for that. I'm just going to send out some links to this, or to the YouTube of this. So view stream to live now. Oh, that's not going to be good. Hey everyone, welcome to today's live session. We're going to be doing view work today. And yeah, so Luis, do you want to just get started?
Yep. Hey guys.
To this. And you can share your screen.
Mhm.
All right, there we go. Okay, cool. So let me just I need to really maximize that. Okay, cool. Looks good.
All right, guys. So, hi everyone again. Today we're going to continue working on the secret auctions written in Vue. And so let's get started. First of all, I did some prior work just to um, to do a little bit more in this session. Yesterday's session was a
First
bit
of
of
all, sorry.
uh, yeah. Yesterday's session we had we tried to do the expectation was to have a little bit more of the application done. So we're aiming to actually get to that point in Vue. Um, so yeah, um, I'm gonna go over very quickly some of the changes that I did or the prior work that I did for this application. So first of all, we have the new version of Griptape 0.9.0. Yesterday, we did announce the release of this version. If you are interested to see exactly the changes that we made, go and take a look at the release notes on GitHub, and you'll see uh, the full backlog there or change log. Um, Next, well, for the first thing, the first part of the stream is going to be focused on creating on two things specifically. So the first thing is creating a component that can show um, the secret balance of a user, and the second thing is to create a component that we call a wallet that essentially will take all the SNP 20 tokens that we have available for the hackathon and display them in a list, and also looking at all the balances for each of those. Sorry, guys. And so let's get into that. So, first of all, well, as you can see, we're using 0.9.0. Then I created a folder with a components named components, and I created two components. The first component is called secret balance, which is a component that in which we are going to show the balance for the account that is currently selected on Kepler, and the wallet, which will contain all the balances or show a list of all the SNP 20 tokens and also the balances for each of them. We still have the contracts I added a folder called data, which contains all the different tokens that we have available, and also all the information related to each of those tokens. So let me just format this a little bit. There we go. So as you can see, we have secret, plan B, girl, and all of those. If you are interested in getting those, go to the glossary subpage of the hackathon section on the docs. I added a layout. It's not important right now because I don't want to focus on non-Griptape related stuff. And finally, we have I added also pages that for, in this case, let's say the index or the homepage, and another page called auction, which will be the focus of the second part of the stream. So let's get into it. So first of all, we want to create the secret balance component. As I mentioned, what we want to do here is to write a component that will show the balance for, the secret balance for the account that is connected from Kepler. So the first thing I'm going to do, I want to have these three states. The first state will be to, when it's loading, just show a loading message on the screen. In case that is not connected to Kepler, or for some reason the application is not bootstrap, then show a button to show the balance. And finally, if it's not loading and if it's already connected, then just show the balance there. So in order to show the balance for in this case, for the account that is connected on Kepler, we need to use a function called get native coin balance. So I'm going to import from secret.griptape get native coin balance. And in order to show the balance in, first of all, I'm going to create a state variable to bind the value that we're going to get from the get native coin balance. So let's create a balance ref, maybe a string. Undefined. The next step will be to create a function called getBalance, which will get the balance for get native coin balance. So I'm going to call that function. It returns a promise that returns a string as a result value, type value. And then I'm going to put the result or set the balance of value to the result. Finally, I will export the balance. For now, before I implement the button and the loading, I'm just going to render the balance so you guys can see the result. So this is my application running. Oh, I was playing a little bit, guys, so sorry about that. And before I move on, I'm going to import the component. Right. So let me just check my console to see if there's any issues. Yeah. Finally, I'm going to. Okay, so at this point we have the get balance function. We are not calling it, and in order to call this function, the most easy way of doing that is when this component gets mounted, just show that run that function, right? So unmounted, if I try to get the balance, and you'll see that we're going to get an error trying to do this. So let me refresh again. Hopefully you guys are going to be able to see the app and see the console. Okay, so as you can see, we get an error that says that no address available. And the reason for this is because you need to asynchronously load Kepler. So because you don't know exactly when Kepler is going to be available when you bootstrap your application, or when if you already bootstrap the application when you load the page. And also, you don't know if someone already ran the bootstrap function to bootstrap the app. You'll need to find a way to somehow have the ability to listen at a certain point when Kepler already loaded, or in this case, the account provider is available to provide, in this case, the address. So there's a new, well, we're going to go over a new set of APIs called the events APIs. These APIs have the ability to provide you to different types of events, in this case, that you can listen to. And Griptape will have the ability, or internally will emit the events, so you can listen to those events whenever they happen. In order to do that, we provide functions that we call event handlers. So essentially, an event handler is a function that you can pass in a you can pass in a callback that that it will be called whenever that event happens. Okay, so in this case, the event handler that we're going to use is on account available. And if we take on account available, call it, we need to pass in a callback function that will be called when the account is available. So in this case, the thing that we want to call when the account is available is a get balance function. And obviously, we want to start listening to that event when the component gets mounted. So let's see if that worked. So if I reload, you're going to see that now we are getting the balance of the account that is currently selected on Kepler. So if I go to Pulsar, I can see that this is the amount that I have on this account. So cool. Now we're showing the balance, and as you can see, well, it is being called when the account is, in this case, on the account when the account is available. Now there's something important that you need to know about using event handlers. So the anatomy of an event handler is the same for any event handler. So all of them start with the on prefix, and all of them receives a callback function as the first and only parameter that it has. The other thing that you need to know is that you need to handle you need to free the let's say the listening of the events when the component gets destroyed. Otherwise, you will get a memory leak. So in this case, we're going to use the on what's it called on unmounted function to stop listening to the on account available. And to do that, I'm just going to create a variable that will hold a callback function. Well, in this case, a function that the on account available function returns that actually stop listening or remove the on account available listener once the component gets destroyed. So in this case, I'm going to call it stop listen. And then finally, I'm going to type it. Let me check this, guys, because I think I didn't reinstall dependencies. So let me reinstall my dependencies. And for sure, for this, you will need 0.9.0 for this. This particular feature that I'm describing, you'll need the latest Griptape version. So let's wait for this to install all the dependencies, and we're going to move forward. So in the meantime, we're going to implement the loading and the show balance function. So for the show balance will be super simple to implement, which essentially is just calling all in the bootstrap function from Griptape. So to show the balance, we need to, when the user clicks Bootstrap, the application, and also we need to set, we'll need to add two more states, one for a loading state and one for the if the account is connected. So now that we have everything ready, let's start the server again. Let me also restart the reload the window. So I'm going to reload the app just to see if everything is working. Okay, cool. Now, finally, well, I added two new states. So the first one is the loading, which is going to call every time I get the balance. So I'm going to start setting the loading to true if when I start getting the balance, and after the promise gets resolved, then I'm going to set it to false. And for the is connected, it's going to start with false, and then I can set that here to true when it's already connected. And then conditionally, I will show either the loading message or the button in case it's connected or not. So if it's connected, well, it's loading, sorry, or loading. We're going to show the loading. The else if in the case that it's not connected. And finally, the else. And let me export balance, loading, and is connected. Okay. Move this to the top. And I think that's pretty much it. Yeah, so let's see how that works. In this case, I need to refresh. There we go. In case that we are not connected to Kepler, and we want to show the balance, well, in this case, Kepler pop up because we were already connected. So let me clear out this. We can show the balance. Kepler will pop up. I enable it, then we can get the balance. And well, you might not were able to see the loading, but because it flashed, but yeah, the loading state is there. So finally, gonna just remove this, and as you can see, the balance is being shown um, as an integer representation of that number. So we have an API to help you format numbers, which is called coin convert. We might want to change the name for this function in the future because it's more formatting than converting. But um, essentially, what this does is it helps you convert from a decimal representation to an integer representation of uh, of the of the number of any number that you're dealing with. So in this case, I'm going to use coin convert. I'm going to pass in directly to the template to use it, and pass in the balance. Again, you can pass in the number of decimals that this number has. In this case, for the native coin secret, it has 6. And then you can tell whether you want it from the integer representation or the decimal representation, which we label them as machine and human respectively. So in this case, we have a machine number, let's say, because it's the integer representation. Then we want to have the human or the decimal representation of the number. So we're going to call it, we're going to refresh the app and see that we have the number formatted, right? And that's it. We have a component that shows you the balance for, in this case, the native coin, and it uses some new APIs like the events APIs, in particular using the on account available event handler. Now that we have the component to show the balance, we can move on to working on the wallet component. And the wallet component will be a little bit more complex, but at the same time, it's really simple to do. Just there is a particular problem that we need to address that I'm gonna go over very quickly. So the first thing that we need to understand is that we need to show from a list of tokens. In this case, those are described on the tokens.json file. We need to iterate over them, getting its addresses, and generate contract clients that help us run the get the balance query on those SNP20s. So one way you can solve this is by writing the contract definition for the get balance function. And then once you have the contract definition, use that to dynamically create all the contract clients. In this case, one thing that Griptape provides is that you don't need to write contract definitions for SNP20s or any SNP any SNP standard, let's say. So we have already built-in definitions that you can export. You can import into your app and right away start working with SNP20s or SNP721s. In this case, we want to interact with SNP20s. So we're going to import the SNP20 contract definition from Griptape and create dynamically the contract lines for each of the entries of this JSON. So that's the first thing that we are going to do. So first of all, we're going to import the JSON. The JSON file has all the required tokens. Then we want to create a function. I'm going to see what the error is that we're going to call init contracts. And this function will, for each of the tokens that are on the JSON, will dynamically create the contract clients required. So in this case, let me see what the error is here. Tokens is going to Kinofy module. Consider. So resolve JSON module. I guess this is like a Vue 3 issue. So let me see. Okay, I think this is a TypeScript issue actually. So let me go to tsconfig and I will add compiler options here. Going to rerun.
Is that causing an error outside of just the IDE, or is it just that the IDE error that's bothering you?
No, I think it's TypeScript. Yeah, therefore it's only on the IDE.
Yeah, you're seeing the red line. You don't like that.
Yeah. Okay, so yeah, we just needed to add. If you created your project with Vue 3, then add the result JSON module property on the compiler options in your tsconfig.json file, and that should be enough to solve the issue. Okay, so now moving on, we need to iterate over to, for each token, we need to create a contract client, right? So I'm going to call the for each function because it returns an array, right? And I'm going to use create contract client to create contract client for each token. So in this case, I'm going to use a symbol to as the ID, the address, and definition will be the snip20 definition. So in order to import the snip20 definition from Griptape, you need to do a snip20 def. That's pretty much it. Something to note is that we are not getting the result for each create contract. We're going to reference each of these contracts using the contract registry, and in particular using the ref contract function. So now that we have the init contracts, we want to call that init contracts on the unmounted. And once that we have those contracts, we also want to Well, actually, that's it, right? We want first of all to need the contracts. Now, for each of these contracts, we want to get the balances. So in order to get the balances, we first need to get the contract from the contract registry, and then we need to call the get balance method on the contract client for each of SNP 20. One extra thing that you need to do, because we're in TypeScript, is to add the type for the contract that gets created. Actually, it doesn't really matter too much if you add it on the create contract, because we're not getting exactly the result here. But when you reference the contract, you'll need it. And the same, there's a type that you can use for that, which is the SNP20 contract type. So now I'm going to create a function called get balances, which will get the balances for each of the SNP20. So again, for each token, what we want to do is to get the contract from the contract registry and call the get balance function. So I'm going to use the map function, and I'm going to explain why I'm going to use that in a moment. So first of all, we get the contract from the contract registry, and then we type the return type, and we pass in the address or the ID. So ref contract can either use the ID or the address when you defined the contract line to get the contract. And once you get the contract, you can call the get balance function. So as you can see, here's a query, and that's pretty much it. Now, as you can see, this will return an array of promises. And this array of promises are going to be promises calling the get balance, the promise returned by the get balance, right? Now, this for sure will work, and we are going to do we're going to actually get all the promises, and after we get all of them, we're going to wait for all of them to resolve so we can show all the balances.
But this is concurrency we're doing right here, right? You're querying them all at the same time, not one after the other.
Yeah.
Cool.
And waiting for all of them. So now, before we actually call the get balances, what we want to do is to filter out those contracts that we have viewing keys for, because these are SNP20s, and the get balance query requires the address and the viewing key in order to work. So before I call the get balances, I'll need to filter out those tokens in which I have already a viewing key. And in order to do that, we will need to introduce a new API called Kepler Viewing Key Manager. So this is part of the viewing keys module, or the viewing keys API. And these provide a set of classes that helps you to manage viewing keys using local storage on your browser. So essentially what we're doing is that every time you interact with either the viewing key manager or the Kepler viewing key manager objects, you will end up storing them on your local storage, and therefore all the other APIs that requires a viewing key can get that from the viewing key manager, and therefore from the storage. So in this case, we're going to use a Kepler viewing key manager to let Kepler handle the creation and the storage also on their servers for the viewing keys, or not on their servers, but under the browser extension. So in this case, there's a method on the on the Kepler viewing key manager to see if you have already a viewing key for a particular token or for a particular contract. In this case, we want to pass in the address. So get will return undefined in case you don't have a viewing key. So for all of them that are not undefined, then I can call the get balances. And let's see how this looks when I run this function. Now there's another thing that we need to do before we can see results. Let me just run it. Import it to the index. And put the wallet right after the secret. Okay, so well, I didn't.
You need to wait until until we make sure we have Kepler.
Sorry. It should evaluate to false to not add in. Okay, so as you can see, we are getting an empty array. But there's a prior step that you need to be aware of. So Kepler Viewing Key Manager and the Viewing Key Manager API will, in this case, depend on the account provider to be executed or to be initialized. In this case, the account provider is a Kepler account provider, so you need to wait when the account is available so you can actually go ahead and use the Kepler Viewing Key Manager. So in this case, we need to do the same approach as we did with the secret balance component. In this case, we need to use the unaccount available handler, pass in the callback, initialize the contracts, and get the balances after. At this point, we're ensuring that we are getting correct results when calling the Kepler Viewing Key Manager.
It probably doesn't make it. It probably doesn't matter. But can you initialize the contracts prior to the account being available?
Sure. Yeah, you can. This is also valid.
It doesn't make sense. Yeah. Okay. Cool. One thing I just want to point out quickly that you may be wondering, and I'm not sure if people are watching are wondering. What you see, what he's doing is he's filtering the Kepler Viewing Key Manager and then passing in the token address, right? Then he's doing a map and he's grabbing the contract by the token address and then just running get balance. So one question you might have is like, how does get balance know? How does get balance know what the viewing key is, or even what the address of the person of the address of your wallet that's getting the balance based on? And that'll be probably a later discussion of context. But basically, to make it really short, the contract definitions are able to get information from the Viewing Key Manager API about viewing keys by contract. So you get that for free. So as long as you have a viewing key and as long as you have a viewing key for a contract query that requires a viewing key, you don't have to actually pass it in. It'll just be able to get it. So anyway, I don't know if we went over that before. Have we gone over that, Luis?
No, I think we were not. Yeah. Yeah, we're going to go over more advanced features of how to build your contract definitions, and that's one topic. The thing that Sandy mentioned is one of the, I think, most important features of the
Yeah,
contract definitions API.
just for now, if you're wondering, I don't understand how it gets the balance if it needs a viewing key, but you're not passing it in. We'll go over that later.
Yeah, just you need to just to trust us that the get balance will just work. Obviously, if you wait for the account to be available. Okay, so this is really important. So take into consideration that every time you wanna you wanna execute any query that requires an address or a viewing key, you need to wait for the account to be available to run that. You can run queries directly unmounted and not being wrapped by the on account available if they don't require an account or an address or a viewing key. No problem. But if it requires, then use on account available. And dispatch or free resources as needed. Okay. So now we have the promises, we are filtering out all the tokens that we don't have viewing keys for. In this case, we don't have apparently any, I think. I think I deleted my... Well, I do actually. Oh, well, yeah, I do for all of them actually. And this is a result that we get from all the promises being executed. As you can see, we have the balance for each of the tokens right here in these promises. So now that we have the promises, we want to wait for them. So in this case, these are the promises themselves, but we don't know if they are resolved or not, right? So we can use a particular API to wait for them. So I'm going to call it result await promise.all. That and pass in the promises. Obviously, I need to make this function asynchronous. And then if I go ahead and call result and we wait for sure. We're going to get all the results for all the promises that were executed, right? So now we are going to get the balances. So in this case, I'm going to call it balances, result map. Well, I need to filter first those that are fulfilled. This is filtering the fulfilled ones. I remember yesterday Sandy asked about if they were, all of them were fulfilled. And the reason is all of them will be, well, the answer to that question was no. Well, was yes. All of them should be fulfilled at the end of the execution of this function. But some of them might not be fulfilled, might be rejected. In this case, we are actually preventing for any of those to be, well, theoretically, we're preventing them for any of these queries to be rejected because we're filtering out the ones that we have a viewing key for. But there might be reasons that other ones could fail, right? Could be rejected. So this status is in terms of the promise itself, can be either rejected or fulfilled. So that's the reason why we still need to do the double, let's say a double check there. So and finally, we can get token status, token value, balance. Well, balance. We're getting an error here because apparently on the type system, for TypeScript is not able to, well, at least it doesn't have the promise setlet result doesn't have the value on it, like the value property, and that's why we need to ignore it right now. But yeah, we just trust me about what we're getting here because that apparently is an issue of the compiler, but should work. Let's see now the balances. So as you can see, all of them, we have all the different balances for all the tokens. And this is not the best way of doing it, but we need to find a way to relate each of the balances to each of the tokens that we have. It's not the best way to handle this, but right now, when you submit a bunch of when you get a bunch of promises and pass them to this function, the result that you will get from this will be in order, and that means that it will respect the order of all the promises when you pass them in. So we're going to take that into our advantage just to associate the balance with the correct token.
Luis, the result that you get back doesn't have the contract ID or the token or anything that we can reference it. Is that why you need to do it that way?
Yeah, exactly. Yeah, it doesn't have it, but if it have it, I think we should be able to.
Maybe we could. I wonder if we could update the Griptape's response to queries to just add the ID of the contract that returned it or something like that to that object when it comes back. Just give you some basically pass back out context with the query.
Yeah, that's a good idea. Yep.
Cool. Anyway, just a thought.
Okay. Yep. So now that we have the balance for all these tokens, actually, before I move on, we haven't even got anything on the screen, so it might be confusing for you guys on the browser. So I'm just going to for each token. Token shall be so there you go. And then I'm going to yeah, I don't think I can mutate. I can mutate the tokens, but I'm just going to create a balances. Hold all the different balances. So in this case, ref, the type will be string. Well, actually, it won't be undefined. I'm going to start with an empty object, and then I'm going to call this. Sorry for the name, guys, but just for keeping simple. We're going to iterate over again the tokens, and finally convert it to balances. So in this case, token address or symbol, I guess, equals to token oops. See how balances looks. Okay. Cool. And finally, we're going to show the balance for each token. So in this case, we want to show the symbol here. And maybe I'm going to wrap this in span. And also put another span for the balance itself. Balances. And finally, this should show the balances for all the different tokens. Let's see. Okay. I think I can remove this actually. Obviously, I need to refresh because the on account available won't trigger. Oh, whatever. And well, finally, we was able to show all the balances for all the tokens. The only thing that is left, I think, is to, in case that you don't have a viewing key for a token, then being able to get the viewing key somehow. So let's say that I don't have a viewing key for any of the tokens. As you can see, I won't get any result here. So I want to show a button when I don't have a viewing key for a particular. So in this case, I'm going to wrap this under with. I'm going to wrap that the token and the balance, and then if I don't have a viewing key, I'm going to create a button called show balance. So in this case, I'm going to create a function that will evaluate if I have a viewing key. So as viewing key, this needs an address, and you need a viewing key. In this case, again, the viewing key manager. Passing the address, and then type of key. I'm going to export that function. I'm going to conditionally render this if it has a viewing key, and in the case that you don't have a viewing key, just show a button. In this case, you can see we have all the buttons there, and now I want to bind a particular function to this button when clicked, so I can add the viewing key or create the viewing key. So in this case, I'm going to bind it to create a viewing key. Create a function. And export it. And this function is asynchronous, and you'll need to use a Kepler viewing key manager.add method. And the add method required you to pass a base contract, or a contract in this case. So I'll need to get again the contract from the registry, which is a snip 20 snip 20 contract. Requires an address. I'm going to pass in the address here again, and then I can pass in the contract. And you'll need to wait for this, because that will pop up Kepler for you to create the viewing key, or in case you have already a viewing key on Kepler, it will get it. So the last thing I need to do is to pass in the token.address here, and I think that should be it. Now again, as you can see, well, ignore that viewing key for now, but you can see every time I click, I get the proper viewing key. And lastly, we need to update this accordingly. So in order to do that, I'm going to create a reference to the tokens, I think. array of any. And I think it resolves this to each of the tokens. So I'm just going to create an interface for the tokens here. Hmm. Okay. I think I'll need to change. Okay, guys, so let me see something first before I move on, because, oh, sorry. It would be weird to handle references. You always need to use a value property of any reference. That's pretty much it, I think. And then finally, I think I'm going to, for all of you guys who were part of the React, stream that we were spending too much time just figuring this out, I think I'm just going to do the same approach here. Just waiting for, actually putting them directly on the tokens. So I'm just going to quickly refactor this to match that. So first of all, for each of the tokens, we're going to add the balance to each token. So in this case, tokens values for each, and then token balance, balance, and it has Vue. So let me bear with me a little bit, guys. I just want to fix this issue, but I need to be able to remove some of the typing things. Let me just see how this works. So you have a token. The token info is role matches is call. Okay, so what I'm gonna do actually is to remove this, and then what I have to keep things simple. So in this case, the only thing that I need to change is let me show this. The token. Yeah, so this won't work. Let's remove that. Okay. And we need to remove or we need to add if it has a viewing key on each token. So in this case, I'm going to create a viewing keys object here. So you're not familiar with all this typing stuff, don't worry, because you don't need to deal with it for certain. Well, I'm dealing with it because we need to separate the models that we're getting from the JSON from the models that we're getting that we need to use to show whatever we want to show. So I'm gonna separate that just to show, just to being able to actually be reactive. But you won't need to do this if it comes from any other source. So the last thing I'm going to do is I'm going to create a viewing keys object that will have the key will be the symbol and the boolean will be if you have already a viewing key or not. And for each token, when getting the balances, we're going to check if as a viewing key. And in case you have a viewing key, then I will check if I'll set the previous token to true. And then I'm going to use that to conditionally render the each of the tokens. So they should work. Oh. Carrier property is self-undefined. Didn't export it. Okay. Okay, so now we're getting that. And I'm going to conditionally render the button. Okay. And finally, when we add the viewing key, we're just going to add the, and to keep things simple, I'm just going to add the symbol here. Now pass a token. Well, actually, I'm going to just pass a token. Token.address. Key is token.address value that true. And here, I'm going to pass the token. So what I did was I created a new model to check if there were viewing keys for each of the tokens, then initialize them when we were get the balances for each of them, and then finally when creating the viewing key or adding the viewing key, just set that to, this is not address, this is symbol, setting that to true for that particular viewing key after the promise for the add function resolves. So in this case, we're going to have viewing keys for the first two. If I add more, I'm not getting the, obviously I'll need to actually call get balance again. So what I'm going to do is get the balance only for those who I'm creating it. I already have a contract. So I'm going to get the new balance for the contract that I'm creating the viewing key. And then in this case, I need to call the balances dot value token dot symbol equals the result dot balance that amount. So now that we have, once this loads, every time I get the balance for each token, I'll get the balance and get the, well, get the viewing key and get the balance for each token, right? Finally, I can again get the coin convert to format balances as needed. Actually, I can just do it here. I'm just going to do it there. Convert balances. In this case, we need to get the number of decimals it has. And finally, the representation, which in this case, we want the human to be shown. So as you can see, those are the balances for each token. If I go to Kepler, I can see it here, right? So I have 49 blind, 4 girl, plan B for plan B, 230 Powell, and so on. So I think we have also, I'm going to create a new folder here for the images. We have images for these tokens. So forgot to copy those, but we can just go to the secret options in React and go to the public. So we have this set of images, and we can just copy and paste them there, and maybe put an image here. So for each of the tokens, we are going to take those tokens, and in this case, we set the tokens as the name of the images are the symbols. So that makes it easy to actually show the image on the screen. And maybe we'll need to, I think, get the secret plan girl, whatever. So let me just see. So assets. Let the server to do the same. Folder assets. And now we can show the images for each token. I can style it, but I'm gonna just do some simple style. Well, inline style for each of the tokens. And yep, so as you can see, we show all the different tokens with all the different balances and create viewing keys for each of them if necessary. All right, so that's all for this component. As you can see, this one was a little bit more advanced because we use many APIs combined, like the create viewing key, the viewing key manager, the event handlers, and the contracts API, obviously, to get all the different balances. So, and obviously, the contract registry to being able to get all those all those contracts and call them whenever it's necessary. So, but at the same time, it just demonstrates how all of them are cohesively integrated between each other. So you can actually do that with this, with this amount of code, which is really impressive for the amount of functionality that we are adding. Okay, so now we're going to move on to creating the auction page. I think for the auction page you'll need to create to have some router mechanism in your application. So in this case, I already have one implemented. So I'm just gonna go and set the layout for this particular page. For now, all of this layout thing and whatever is up to you, is application specific, but I have a component that describes the default layout of any page. Well, actually, that's not true. The default layout is actually already implemented. I have a column class that help me represent a column on any page. Because I already have in the app.vue the layout. So I think in this page we want to show the auction, all the auction information maybe, and this page will have features like make a bid, close the auction, and certain features that we are going to add later in the development. But for now, showing the information, I think, and put in the sections that we need will be enough. So in this case, for the layout of this page, I think we just add maybe the token, the pair of the tokens, and then show all the information that comes from the auction info query of the auction contract. So let me show you what I did in terms of the contracts of the auction contract. As you can see, right now we just have one query, which is the get auction info. We used it in the first live stream to show information that is specifically returned by this query in terms of the of all the auction, but we just wrote like a piece of all the information that you need. So in this case, I just added all the different types that describes the auction info response. In this case, the auction info has a sell token, bid token, sell amount, minimum bid, description, auction address, and SAT and status. So I think it will be a good idea to show that information in the auction page, and then from that point, add the vid and all of the other functionality. And also, I think that we might want to adjust the current way that we're showing the options, but I think we'll do that later. So in the auction page, I think we want to show all this information. So let me move this to, well, that's fine. Let me go to the action page. And so in order to do this, I think I'll need to pass in or add that page to my router. Auction pages, auction. Then set a path for it, so auction, and then maybe an ID. In this case, the ID will be the address of the token. So I'm going to call it address. And I think that's it. Now on the auction page, I need to first get from the router, get the well, actually, before I do that, I'm going to create a link on the index page so I can get that to that page, right? So at this point, that page is already mounted. So I'm going to create a new router link. I'm using Vue router to do this. You can use whatever you feel or you like, if you're comfortable with. So I'm going to create a path. In this case will be auction. Just format this a little bit. Auction / and then the address. Auction.address. Now, if I go to my application, I can see that you can see in the URL box, I can see that where the URL have changed. And if I go to the auction page and maybe title, we can see that that's working, right? So I'm just going to try to put that there. And let's now get the address from the URL so we can query the proper contract and show the auction info information in this page. So I'm gonna use a useRoute function from Vue router. This have a path. That is ramps. In this case is address. So this is the address of the route that we are getting from the route. So in this case, let's just print that. Or actually, let's create a state just for you to see that. So so we export the value and then we can let me just see what the error is here. You need to define either. As you can see, if I go to the page, I can see that we are rendering the address. And if I go back and go to Powell secret, we can see that this is the other address. So now that we are able to get the address from the using the router, we can start getting information and show it in the page. So for that, first of all, we'll need to create the contract client required to access or to use this contract. So again, need contract. This will require us to use a create contract client. And the ID for this, in this case, I think it does make sense to use the address. And for the definition, we need to use the auction definition that comes from or auction that from contracts auction. What's going on? Okay, so okay. I think this is unnecessary. And I'm gonna unmount again, mount it, initialize the contract. So at this point, I have the contract. What I can do also is to get the information of the auction. Let's call it auction info. In a reference, so I can use it, and I can even get the information directly from the reference that I got back from the create contract client. I'm just going to do it the same way that we were doing it. So in this case is function get auction info, then contract again using the ref contract function auction auction contract. Int address, and then contract.getAuctionInfo, and auctioninfo.value equals to contract.getAuctionInfo. GetAuctionInfo returns a promise, so I need to wait for that, and that's pretty much it. Right? And then let me just format this very quickly. Here. There we go. Then after, I can just get the auction info, and that's it. Now I can show all the information on my template. So let's start by adding the auction info. Well, I need to export it for sure before I start doing anything. That's not needed, but the auction info is and auction info can be we'll need to conditionally render this component if auction info is not undefined. So auction info dot I think pair. I don't know exactly what it show. Let me.
You want to console log auction info so you can see it.
Sure. Info dot value. So, okay. Cool.
I don't think there's a pair there, Luis. Can you go back to the object?
Yeah, actually, here's a.
Oh.
Yeah, sorry,
Did you not get type conclusion when you were in the template?
I do. Oh well, no, in the template now. Yeah.
You don't get it there, so you can't see. Oh, that's too bad.
Yeah. I remember, guys, when I was playing with Svelte, that worked, and I was really amazed.
You get type completion in the template and stuff.
Mm-hmm.
That's great.
Yep. But yeah, in this case, we need to show. Well, I think the title. There's no such title thing, or maybe it is, but for now, we just. I'm gonna start to say auction, whatever, and then here maybe either as a I don't want to put a table, but let's do a
Luis, maybe we should. What about showing the user's balances based on whatever the auction types is, whatever the auction tokens are?
Yeah, sure. Let me just maybe show the, let's say, the description in a paragraph.
Cool.
Description. Maybe in a description list. Maybe description title. Well, also I need to put the and at, which is another thing that you want to use. I think this comes back in already formatted from the contract, so let me see. Auction info ends at auction info description. Where is my description? Yep. Auction info the value auction response auction info, then response. And this is not actually response, but rather this is action. So and sat, then maybe the status, let's say. That makes sense, but Now, yeah, it's a good idea to show both tokens. So let's actually render both the tokens, right? The cell token and the bit token.
Yeah, so
Token. And what information do we have from the cell token? So cell token is a token. Token has a contract address and token info. Token info has name symbol. Okay, so let's do the cell token dot token info dot name. And here the token is the token here.
do you think lack of type support there leads to people creating a lot of, that's cool, it worked, a lot of computed properties so they can directly access them and then they can, you know?
Yeah, that might be. Well, I think it's kind of bad practice if you want to do that directly, because yeah, if let's remember that a computer property needs to compute, needs to do something. So if you're not doing anything, then it doesn't make sense to have a
Well,
computer.
could you destructure at the below in Vue, and then you can access them directly as just the base. So destructure, so you can just type in nzap as opposed to auction info, or no?
Well,
No,
in the template, yeah,
never mind.
yeah. In the template, you can, but you could do it like here or something.
No, it's alright. Whatever.
Yeah. So okay. And obviously this data structure is a little bit, complex, let's say, for the kind of information it has. But you might guys maybe find some other contracts that doesn't have this kind of
Yeah,
data
but
structures.
you do all that work to type it all like that, and then you don't get the type support. It's kind of annoying. But yeah, I guess.
Totally. Okay. So yeah, this is all the information for the auction. The sell token is Powell. The bid token is secret. Cool. Now let's actually
Well, we should get a min bid and the amount of the amount of the
oh yeah.
the sell amount and the minimum bid, right?
Actually, I'm gonna put a span here for the name. And here is, I could put here the amount, right? Amount auction info dot sell amount. Sell amount, I think, or something. Over.
Can you go back? So if you look at this right now, no, leave it here. Sorry. Yeah, go. Yeah, just where you are. Yeah. You notice how the bid token doesn't have the decimals there? Oh yeah, it does. Okay, never mind. Okay, cool. You can use that to format it. That's great.
Yep.
And then yeah, so you would want the sell amount, and then you want the minimum bid.
Yeah, I think you're gonna have another entry here. Amount. Sell amount, and then minimum bid. So I need to format those numbers by
Auction info bid token Decimals. Token info decimals.
This won't look very fancy, guys, but again, to keep things simple, I don't want to teach you Vue, so no, but I don't think that will look good. So just gonna do a computer property. So
okay.
Computer properties. So this is a cell amount equals computed. If auction info dot value undefined, and then return coin convert auction info. Here I can do the sell amount. Sell amount value. Sell amount, and also sell amount, and I need the sell token, and from the sell token I need the token info, and from the token info, sorry guys,
Decimal.
Yeah, decimals. There we go. And now sell amount here, then decimals, then human. Now, having it here. Let's have to type number. Token info. What? Oh. Okay. There we go. Again, it's not super elegant. Well, I think it's kind of not that bad. And then sell now here. There we go. And the same to.
So it has 6 decimal points, but because they're all zeros, it just doesn't show them. Is that right?
Mm-hmm.
Cool. Is there any way to force it to show those?
Yeah, I think put in the fixed number.
Oh, cool. Yeah, do that just so that we can see it. Yeah. Nice.
Yeah. Sorry guys, so don't do this at home. Only when no one's seeing. I'm gonna just copy paste this. And that's it. And now the only difference here is the token here. And okay. Let's move a bit actually. There we go. So let's run this again. Oh. Bit token. Beat him out. So one secret, right? And I think lastly, we can show the balances for both tokens, the amount that you have, right? So again, you don't have, in this case, you need to create the contract lines for the tokens that are part of the auction. So we're going to create those in the init contract, and I think we are going to rename it init contracts. So finally, well, actually, we'll need to create another function because this can only be created after we query the auction. So init token contract, let's say. So the init token contracts needs both the sell and the bid token addresses. So let's do cons equals auction info.
So now you're dynamically creating a contract definition for a SNP20 based on the auction that you're in, correct?
Sell token. In this case, sell token. This is again value. Sell token, then token info, then oh no, I don't need to access to sell token contract address, right? And auction info. Yeah, TypeScript will force you to do things right, guys. So remember that. And now I'm going to create the contract lines for both. So in this case, maybe I can the ID, and also the structure the ID. But to keep things simple again, definition. And And now that I created those, I can init token contracts, and then I can get the balances for each of those. So finally, just get balances again function. And let's run let's get the balances for each of those. So I'm going to do it, again with not very elegantly, but contract, and then you know what? I'm gonna create. So I don't want to just do this again and again and again, but okay, that's just it. Cell address and bit contract, bit address, and let's get the balances for each of them. So cell contract, oh, that get balance again, counts await, counts cell balance equals amount balance amount cell amount, well, cell balance and bit balance. This is a bit contract. And then maybe create two states for that. So balance, well, cell balance of string undefined and bit balance string undefined. I'll need to balance cell balance the value equals to point convert. Oh geez, I'll need the decimals again from the auction. So took here for decimals. I'm gonna remove this again so you guys can see. Yeah, maybe this, when you have complex structures like this, maybe you don't want to destruct everything. So so be careful with that. So point convert, cell balance result, and then cell decimals, then human, and cell decimals. Then for the bit, I think you can just cell bit. There we go, right? Finally, export bit amount. What is bit amount? Okay, got it. So cell balance and bit balance, and get balances. Final up again. Available. let's create the fine. Listen and on and mounted. Listen. If listen. There we go. And let's just put the balances somewhere. So maybe after the name of the token. Balance. Balance. Here also. Balance. Balance. I like how it looks. Obviously, we need to put a component. We need to set a component to create the viewing key in case that we don't have, handle all the different cases. I might recommend you guys to have a component like token balance component or something that in which you can show, you can have that logic to show or not the balance and show the proper controls for people to create in the viewing keys. Let me just see what's the problem here because we are not seeing the balances. Did I call to get balances? Get auction info. Okay, it might be the case that we might want to do this. I think this is fine here, but the other ones are dependent, so. Am I calling the get balances? The only reason why this could not be calling is because of the auction info. Okay, so we need to wait for the auction info to. Oh, actually, this is not correct. It might be the case that to handle this dependency correctly, semantically speaking, this is not correct, but it should work. We might want to create another function that handles that. Yeah. So you can see how well I have this balance. This is the sell amount for in this auction, and then for secret, this is my balance, and this is the minimum bid.
Great. And so then you could, for a UI, a developer could put like, you want to bid 50% of your balance or something like that. When we actually built the original secret auctions, this was a big request. Can I see my balance of the different SNP 20s? And for us at the time, it was very challenging to do that because just getting balances for all of them and dynamically and stuff, whatever. Anyway, this is great. I think we're in a really good place. So yeah, the next, I guess, two features will be like, when we can decide which one to go first, is creating new auctions, which is obviously one of the more challenging and kind of interesting parts, and then being able to bid on and close auctions. And that would sort of complete the loop, right? So if you can create auctions, see a list of them all, choose one, see that auction, know what you can bid, place a bid on it, and then the owner or other people can close it, then money can actually start flowing, which is great.
Mm-hmm.
Did that one not work?
I think is because we're wrapping it up on the on account available.
Oh, and on account available doesn't refresh when you don't, because you're routing it directly without a single page. Is that right?
Mm-hmm. I think this is an issue with the on account available. I think.
So on account available though should not so okay, the on account available is waiting for an event in which it goes from not being available to being available, correct?
Mm-hmm. Mm-hmm.
Is there a way to check if it's available and then not, then you, if, then only if it's not available do you need to wait for it to be available? Does that make sense?
Yeah, totally. Yeah, I mean, we can handle that here ourselves. I think that was handled by the on account available itself. I need to check that, but
But I kind of feel like even programmatically, you wouldn't want to be using the event API in order to check if it is available or not, right? There should be like a Kepler provider dot is available, right? Like the account provider should have a, she should be able to ask it, is this, are you ready? You know?
mm-hmm, mm-hmm. Yeah. Yeah, I think there is. And this is because of the change that we made to the last version, and because it wasn't required on the other ones. But there is an API that is called get.
Get Kepler account provider or get.
There's a. I don't know how's it called. It's kind of available. This one
Cool.
is account available, and then if is account available, the
Right.
auction info.
Yeah.
I think if not, handle or listen to the on account available.
Yeah, that seems right.
Oh, whoa. So in this case, we go back to Powell. We can see the auction.
Nice
We
work.
go back to this. We can see that. Okay.
Very cool.
All right, guys.
So yeah, we're only 13 minutes over, but we got a lot done this session. So for React next session, we're going to need to do some quick catch up, I think. But we'll figure out how to do that best because we're now pretty far ahead with Vue. But that's fine. So next one, we're either going to deal with bidding or creating auctions. So I don't know. We'll think about which is which, and I guess we'll let you know ahead of time, or we'll just find out when you come to the next one. But everyone, thanks for watching, and let us know if you have any questions for sure. Oh, this is a YouTube video, right? I'm supposed to say like subscribe or like. Click here. No, actually, I can't do that. Anyway, guys, thanks so much for watching, and we'll be back next week. And tonight, we're actually probably going to be doing, if anyone's actually watching right now and isn't seeing this is on a recording, I think we're going to be doing some Svelte development this week. Is that right, Luis? I mean, tonight.
Mm-hmm. Yep.
Yeah, cool. All right. So yeah, we'll basically see what we can do. We'll do the same thing in Svelte and see you can see the differences. So, okay, thanks guys. Take care.